Hello physics students, today we are going to see if we can get a more conceptual view of what is going on in these position versus time graphs and these velocity versus time graphs. So I want you to take a moment, and here's the question I want you to think about. What would it look like on a position versus time graph if you grabbed a ball, threw it up in the air, and waited for it to come back to your hand? Okay, take a moment, write that down, think about it. And now that you've had that moment to think about it, I'm going to explain what's happening. So a position versus time graph. So if you think about throwing a ball in the air, you got your little guy, we'll say this is you. You have your ball, you throw it in the air, it goes up, reaches a point, and then goes back down. And so the position versus time graph is actually fairly intuitive in this case. It looks like an upside down parabola. Now this is not surprising since gravity is dictated by the equation. We have our position x equals our initial velocity times our time plus 1/2 our acceleration times time squared. So because of this time squared, we would expect the shape to be somewhat of a parabola. And so now we have our position versus time graph. I want you to think of what would that look like if we now graphed our velocity versus time graph. Now take a moment, think about that once again. And now that you've had your moment to think about it, we're going to write what this is going to look like. So when you throw an object in the air, the ball starts off in the hand right there with some initial velocity upward right as it leaves your hand. And then you're going to have your acceleration due to gravity here, pulling down on the object. The acceleration due to gravity is always going to be constant as long as you're here on Earth. And since I don't expect any of you to be throwing balls into space, here we are. And so, if the gravity is consistent, which makes our acceleration consistent, on a velocity versus time graph, that must also mean our slope is constant. So we're going to have a constant slope because the slope of velocity versus time graph is our acceleration. So think about it. We have some constant velocity that we're starting with. And so as we go up, we have gravity pulling down. So our speed is going to go down. And so we have our constant acceleration going downwards until we get to 0. Now at 0, that means we are at the top. This is where we are changing directions. And so this is quite apparent here on our position versus time graph. We're right up here at the top, and now we're changing directions to go back down. And so as an object falls, we still have gravity acting upon it. So it's actually going to start speeding up at a consistent acceleration. So our velocity versus time graph is actually going to go into the negatives here. And so it's going to go in with the same run as we did before. It goes a little bit off the page. I apologize for that. But we're going to start at our initial velocity, and then our ending velocity will be the negative of wherever we start at, because that's the speed at which you're going to catch it in your hand. I hope this was helpful.